Okay, so welcome to the second part of week 4. In this part, we're going to take a look at how to organize modules and how to import modules that you have defined or that other people have defined into your own code. We're also going to take a look at something called comprehensions, which is a cool way, a concise way, a Pythonic way of creating lists or sets or dictionary objects. All right, so off we go. Does anybody have any questions about anything that we did up through, last week? We will be having a quiz for the last half hour here. Any questions? Why do we have to have a quiz? Well, that's supposedly there's no such thing as stupid questions, but no, that's a stupid question. So, no. All right, let's begin. Now, I have my obnoxious kitchen timer with me here to remind myself when to shut up so that the quiz can start. All right. So, a module is whatever current collection of code is running. And the main module, I misspoke about that. A module is a collection of Python code in a file, or that you type manually. And the main module is the part of that that's currently running. Now, the shell itself believes that it is always the main module. And there's a special variable, __name__, that displays, or that contains, or that refers to be really most precise, the name of the current module that you're executing. So if you're in a shell and you ask to see the value of __name__, you get back __name main __. 8 underscores in there. Now, just as an aside, because nobody likes to say ____ 4 times when they're talking about a variable, these variables are sometimes called the dunder variables, the double underscore variables. So rather than ___name __, I could just call that the dunder name variable. But that sounds stupid to me, so I have a hard time doing it. Anyway. Okay, so here we have a program, a little program named Prague2.py. And what this program contains is the Fahrenheit to Celsius conversion function definition that we've seen before. I've put a comment at the top to remind us what the name of this program file is. And underneath that function definition, I have a print statement that is making use of the function, and then I also have another print statement that is printing out what the name of the current module is when I run this module. So if I access this program, here it is. This is a program stored in a file, and I have loaded this thing into my idle editor. And if I run this guy, well, because I'm running this module directly, it is the main module. And so what I get out is, let me pull my program back up here so we can look at the program and the output at the same time. All right, so what I get out is that 80 Fahrenheit is 26.6667 approximately Celsius. Okay, that's the output that I get from the first print statement. And the second print statement says, my name is, and because this is the main module, because this is the module that I executed myself, it knows itself as dunder main. There, I said it. All right. Any questions so far? But what if we have a different program file this program is cleverly named prog3.py, and this program is going to import, this program is going to import the prog2 module that we just looked at. And we're going to use the abbreviation P2 as a shorthand for prog2. Now, when you import a module, it turns out that everything in that module is executed at the time where you do the import. So it's not like you just suck in the text and then continue on. It's like, no, you suck in the text and you execute all of the text of that module, and then you continue on after that module has been fully imported. So we're going to import prog2, and then we have 4 print statements in here in which we are calling the P2 module's F to C function 3 times, converting Fahrenheit 32 to better be Celsius 0, Fahrenheit 212 to better be Celsius 100, and then 76 to whatever 76 is. Low 20s, I'm going to guess. And then this program is going to tell us its own dunder name. All right, so this time I'm going to execute prog3 as my main module. It's going to import, which will cause prog2 to execute, and then it's going to do these 4 prints. Here is prog3, and I'm going to say, and by the way, these are all posted on Canvas, so you don't have to retype these. You can just access them on Canvas. So I'm going to say run module. Okay. Now here are the 4 lines of output that are produced from within prog3. Let's remember what prog3 looks like. Here's prog3.py. And in prog3, the first thing that happens is that prog2 is imported as P2. Now, importing prog2 also executes prog2, so anything that displayed output in prog2 is going to display output here. And that's where the first 2 lines came from. The first 2 lines are actually print statements in the prog2 module. Okay? Now, continuing in prog3, I do, in fact, get told 32 Fahrenheit is 0 Celsius, 212 Fahrenheit is 100 Celsius, 76 is 24.4. Well, it's barely low 20s, but it's low 20s. And because I said run module in prog3, prog3 now says, well, I'm the main module. Notice that in prog2, let me pull prog2 back up here. Prog3 did an import of prog2, and I claimed that importing prog2 is going to execute everything in prog2. What that means is that this function definition is executed, that is, the definition is created. Executing a definition means creating the function definition. Then this print statement is executed, and that prints out that 80 Fahrenheit is 26.667 Celsius. And then this print function is, this print statement is executed. This print function is called. And dunder name in prog2, because prog2 is not the main module, prog2 instead is an imported module, the value of dunder name is prog2. Okay, so what is that any good for? Well, what it means is that if I import a whole bunch of modules, and I'm curious, which functions are from which modules, I can test the module name dot dunder name, and I'll find out what that module's name is, as opposed to the main module, which is the top-level module that I'm currently executing directly. Does that more or less make sense? Yes? Sorry, I can't quite hear.
Why is the second line printed as prog2? I was hoping to print as 2.
Okay, let me put prog2 back on the screen. Okay, so here is the Prague2 module. And I think I can do this side by side. Let me squeeze this over. And here is the Prague3 module. Okay, so I have done the run module command in Prague3. So Prague3 is the main module. Now the first thing that Prague3 does is to import Prague2 using the abbreviation P2. Importing a module means executing everything that that module contains. So when I import Prague2 into Prague3, the first thing that's executed is this definition of a function. The second thing that's executed is this print statement saying that 80 Fahrenheit is 26.666. And the third thing that's executed is this print function call. But Prague2 is not the main module right now. Prague2 is a subsidiary module that's being imported by Prague3. Prague3 is the main module. So, since Prague2 is a subsidiary module, the name that gets reported is the name of the module itself. Basically, it's the name of the file with the .py trimmed off. Did that help? Yeah. Okay, and then once this import statement has been completed, we come down here to do these 4 print statements telling us that 32 Fahrenheit is 0 Celsius, 212 Fahrenheit is 100 Celsius, 76 Fahrenheit is 24.44, etc. Celsius. And then this print function, this program is the main module, because that's the one where I pressed F5. That's the one where I said run module. Other questions? Yes?
So to make these work, you can't close any of them. All the modules have to be open at the same time. Is that right?
Okay, so let me describe what happens, and then I'll see if that answers your question. Let's suppose that you've written a good-sized program, and you need to use a bunch of different modules. You need to use the math module, you need to use the NumPy module, you need to use the pandas module, you might need to use something called matplotlib, which allows you to create plots of mathematical stuff. Have I inflicted that on you already, or is that next week? Actually, no, I inflicted that on other people. I may not inflict it on you. We'll see. But anyway, so your program has a whole bunch of import statements at the top. And when you run your program as the main module, it will import and execute the contents of the first one, like math, and then it will import and execute the contents of the second one, like NumPy and pandas. We haven't done pandas in here either, have we? Okay, so pandas is a spreadsheet kind of thing. We haven't done NumPy either, have we? We will, I promise. We will get there. Does that help? Does that more or less answer your question?
Yeah, I think so.
Okay. Other question?
I want to know where is main from. This program is main. Where is main from?
Where is main from? I'm not sure.
Yeah. Green, this program is main, but it shows the main. I want to know where is the main from.
Okay. We will answer that in a few slides, but let me jump ahead and answer it now. Anytime you run anything in Python, that Python program has an environment of existing variables that it works in. And you can use the function vars to see these variables. A lot of these variables get created automatically whenever you run a Python program. And so if I say vars right now, the output that vars displays is a dictionary. All right, here we have a variable name as a key, and then a colon, and the value associated with that variable name. And it turns out that every time you call any function in Python, you get a whole set of these variables created. And so just by virtue of running this program at all, name is automatically created. Well, I should say in this case I'm communicating with the shell. So name is automatically created as soon as I start my shell, and the shell always believes that it is the main module. So that's how that variable value gets set up. It's done automatically as soon as you run your Python environment. And that will be true whether you're using an idle shell or whether you're using Spider or PyCharm or some other environment.
So it is set automatically.
Yes. Right. Yeah.
Are only Python files considered as modules, or are there any other things that are considered as modules?
Can you ask me that again?
Are only Python files considered as modules?
Okay, good question. Are only Python files considered as modules? Yeah, when you import something, that has to be code that can be used from Python, let me put it that way. But it is the case that it is possible to develop a module using a language like C or C++, and then just provide a sort of a thin layer of Python-like functions that you can call. And this thing I mentioned called NumPy, which gives you vectors and n-dimensional arrays, and the ability to do vector arithmetic and linear algebra and so on, that is actually a bunch of C language code. But you can pull that into Pandas and pull that into Python and interact with it from Python. Other questions? Oh, yes.
I just want to make sure that if you import some program, it will be import and execute only once, right?
That's correct, and that's a really good point.
So if you continue to import another program which includes the former program, so it's like it's re-imported, not it's re-imported from the old source, or it is already in the environment, or just re-executed. So.
Are you asking me if I import the thing again, if it's re-imported or re-executed?
No, I mean, like if I import program 2 first,
Okay.
then I import program 3, which includes
Oh,
2.
all right. So you're talking about another. I will learn to bring a pen I can use on a whiteboard. Let me do that. I can do that right on the fly. Here we've got Prague 2 that defines F to C and has a couple of print statements in it. Then we've got Prague 3 that imports Prague 2 and has some print statements in it. Let me create, right before your eyes, if I can find my mouse, there we go, file, new file. I'm going to call this one Prague 4 because I'm so imaginative. And I'm going to import Prague 2 as P2. And I'm also going to import Prague 3 as P3. Prague, not Prot. And then I'm going to say print my name is okay, so the issue here is I've got this this program file, this module file now, called prog4.py. I haven't actually saved it yet, so I need to save it with that name. And when I run this as my main module, it's going to import prog2, which will execute everything in prog2. Then it's going to import prog3, and prog3 also tries to do an import of prog2. It turns out that if a module has already been imported, it won't be imported again. So when I import prog2 will be imported once. When I import prog3, the import of prog2 again is just ignored, and the remaining stuff in prog2 is executed. And then finally, the print statement here in prog4 is going to be executed. All right, so this guy is going to be prog4, and I'm going to say run module. And just before I do that, let's see if we can predict what's going to happen. Well, we can't predict if we can't see. There we go. All right, so first, prog2 is going to be imported. That means that I will get these two, where's my mouse? There it is. That means that I will get this print statement executed and this print statement executed. So those will be the first two lines of output. Then I'm going to import prog3. And what I claim is that the import of prog2 is not going to happen a second time. So I will not get those two print statements again. But I will get the 4 print statements that are in prog3. This time, because prog3 is a subsidiary module, the name that it displays, dunder name, is going to be prog3, not dunder main. All right? So let me run this. And we got what I claimed. I'm always very relieved when we get what I claim. All right, so we got the first two lines of output. Those are the print statements from prog2. Then we got the print statements from prog3. And notice that prog3, since it's not the main module, refers to itself as prog3. And then I got prog4 executed, the remaining code in prog4 executed, which says its name is main. Yes?
Two questions. The first one is the import is only until that particular program is executed, right? Anytime you want to re-execute, you have to import everything again.
That's correct. That's correct. In fact, whenever I run a module, this is the way things work. Well, it should be the way things work in any environment. Whenever you run something as the main module, it's going to completely forget everything that it used to know and start over again from scratch.
And the second one is, what is the main importance of using the modules? And where do we use them?
Well, okay, let me catch up. Let's go back to where we were. All right, so we started out with way hours ago. We started out with prog2, and we imported that into prog3, and we saw what happens there. Now, let's suppose that I don't want the two print statements in prog2 to be executed when I just import that module. What is the point of modules? Well, I may want to have a module that handles temperature conversions. And I don't want to have to repeat all of that code in every program that I write that has something to do with temperatures. So what I'm going to do is I'm going to create a module named, let's say, tempconv.py that has all of my 9, Fahrenheit to Fahrenheit, Fahrenheit to Celsius, Fahrenheit to Kelvin conversions that I might possibly need to do in one module. And then anytime I need to use any of those functions, I can just import that module. I could say import tempconv as tc, let's say. And then I can say tc.f to c, tc.c to k, without having to retype all that code. So the point of the modules is to I mean, one point of the modules is to avoid having to retype the same code over and over and over again when you want to use some facility that you already defined and debugged once in the past. Okay? But when I import Prague 2, I would rather not have the print statements within that module Prague 2 be executed. I would like to only have those print statements executed when Prague 2 is the main module that I'm currently developing and debugging. I don't want to see my debugging test statements when I'm working on Prague 3 and I'm just importing Prague 2 as a subsidiary module. Okay? So what I do is I can make an if decision by comparing the dunder name variable. I'm getting used to it now. By comparing the dunder name variable to see if its value is main. If its value is main, that means that I'm currently working on this file and I should go ahead and execute some print statements. If it's not main, it must be Prague 2, and that means that it's in fact been imported as a subsidiary module by somebody else, and I don't want to execute those prints. So here's what that looks like. Here is my Prague 2a code. Let me pull that file up. And we can do a side-by-side comparison of this with the original Prague 2. Okay, so in the original Prague 2, I defined my F to C function, and then I executed a print statement, and then I executed another print statement. And that happened anytime I made use of Prague 2, whether Prague 2 was the main module, or if Prague 2 was imported. I almost said a C++ word. Anytime this thing is imported by some other module, those two print statements were executed. But I don't really want that to happen every time. So what I'll do is I'll move these two print statements below an if, so that if dunder name is dunder main, then I will execute my testing statements, but otherwise nothing will happen. All right, so if Prague 2a has been imported by somebody else, maybe a file with a clever name like Prague 3a. If it's been imported by some other program, then the stuff underneath the if here will not be executed. Let's confirm that. All right, so I'm going to run Prague 2a as the main module, and the two print statements are executed, which is what I want to have happen. But now I'm going to create a program Prague 3a.py which imports Prague 2a. And this time, when I run Prague 3a, when I run Prague 3a, and that causes Prague 2a to be imported, well, importing Prague 2 means to execute all of the statements in here. So the first thing that's executed is the definition of this function, so F to C gets created. But the second thing is this if comparison. And because Prague 2a is not the main module, the value of dunder name is not dunder main, and consequently I do not do those two print statements in Prague 2a. I'm only going to do the four print statements that are in Prague 3a, and I just have to remember to use P2 as the name of the module that contains this F to C function. All right, so I'll say run module. Good. So this time I only got the 4 print statements in Prague 3a. I did not also get the 2 print statements in Prague 2a because those were hidden below this if decision. Make sense? All right, well, we can take this even one step further. In Prague 2a, we prevented those 2 print statements from being executed unless Prague 2a is the main module that I'm currently executing, that I say run module. But maybe I would like to have the possibility of executing those 2 print statements. Okay? I don't want them to be executed all the time, but I would like to have the possibility of being able to execute them if I want. So the third sort of logical progression here is to reorganize Prague 2 again. Whoops, sorry, wrong one. Here is a third version of Prague 2, cleverly called Prague 2b. And the change that we've made here is that instead of having the 2 print statements below the if dunder name equals dunder main test, what I've done is if I'm in the main module, I've called a function named main. I could have called that function, banana or XYZ or giraffe, it doesn't really matter, but the convention that people tend to follow for cases like this is to use the function name main to contain the main code that you want to have executed when this module is the main module. Okay, so right now this module is the main module if I say run module, and I missed my mouse button. There we go. Okay, so I'm editing Prague 2b. I said run module within Prague 2b, therefore Prague 2b is the main module. And consequently, when the statements in here are executed, I first define the F to C function. I then define but don't execute the contents of the main function. I then test whether dunder name is equal to dunder main. And because that's true, here I call the main function, which causes these 2 print statements, these 2 print function calls, to be executed. Yeah.
Why do you need the quotation marks around main in your statement?
Good question.
Or do you need them, I guess?
I do because dunder main here, __ main __ is a value. It's a string. Okay. Whereas up here, this thing called main is a function rather than a string. So what I'm doing here in this if statement is I'm comparing to see whether the value of a variable is equal to some string. Like I could ask, if I could say x gets 123, and I could say if x is equal to 123. There I'm comparing the value that x refers to with the integer value 123. All right, so here 123 is an int. In Prague 2b, it's a string. All right, so you could, instead of using the single quotes, you could use a pair of double quotes, a pair of triple single quotes, a pair of triple double quotes, but if you leave the quotes out, then it's just a mistake. Yes?
I'm wondering, can't we just call on the main function without putting it in the if statement?
Without putting it, I'm sorry?
In the if statement, can we just call on the main function? Can we just call on the main function without putting it in the if statement?
Oh, without the if.
Yes.
Yes, exactly. And in fact, that's what I want to show in our revised version of Prague 3, so since I have created a main function, which has the name main and has some statements in it, since I've created that main function can be called from other places. And here in Prague 3b, I'm importing Prague 2b. I'm using the F to C function 3 times to convert Fahrenheit to Celsius temperatures. But then I'm also calling the P2 modules, the Prague 2b modules, main function. So I can execute the main function optionally, if I wish to, from within this other program, Prague 3b. Okay, so let me do that. Run module. Okay, and now the difference, let me show Prague 3b compared with Prague 3a. Or maybe compared with Prague 3. Let's look at Prague 3. I know it's hard to carry all this stuff in your head. I am recording all this, and you can watch it at half speed on YouTube later. Or at double speed, whichever you prefer. Or not at all. Okay, so here's my original Prague 3. My original Prague 3 imported Prague 2, which had 2 print statements in it that were always executed. So those 2 print statements were executed, and then these 4 print statements in Prague 3 were executed afterward. Over here now, I'm importing Prague 2b, but Prague 2b has now hidden those 2 print functions in a main function. So I don't get any output from doing the import. I do get these 4 print statements from Prague 3b. Okay, so that's these 4 print statements. 32 Fahrenheit is 0 Celsius, 212 is 100, 76 is 24.4, and this program is the main module. And after those 4 statements have been executed, after those 4 prints have been executed, I'm executing another print statement saying that now I'm going to run Prague 2b's main code, which I do by explicitly calling p2.main. And when I call p2.main, I get those 2 print statements that are contained within the definition of p2, that are contained within the definition of Prague 2b's main function. Clearly, I got to come up with better file names. Yeah.
Or what if I include this if statement in definition of main?
Let me, okay, so we did 3a. Let me see where we are. Okay, so we showed 2b and 3b. We showed 3b and 3a. Okay, so I just wanted to see where we were. We talked about the vars function that displays variables. We only have 3 minutes left before the quiz is going to start. So this comprehension stuff, this starts on slide 20. We will punt and do that next week. All right? So let me answer this question, and then we'll be ready to take our quiz. Go ahead.
I think it's Prague 2b. What if we include that if statement just below the definition of main function, like that?
You mean here?
No, above to bring.
Oh, you mean You mean here?
Yes.
Well, this will, I can do that. I can say if dunder name is equal to the string dunder main, then do these two print statements. But now that defeats the purpose of. But now that hides the two print statements again.
Yes.
Yeah.
Even if Prague 2B is at present main module for me, it will still have the two print statements.
No, if Prague 2B is the main module, then this test within main's definition is true, and this test below main's definition is also true.
Just delete the lowest if statement. Just include it into the.
Oh, I see. You want to do this.
Yes.
So you want to execute main every time, but main is only going to do anything.
Last line is delete too.
Sorry?
Delete this last line.
Now you can't keep changing what you're asking me to do.
Sorry.
So you get rid of that.
Yes.
Now no output is displayed.
So it's somehow equivalent to the initial version of Prague 2B, right?
No, because the original version of Prague 2B.
Yes.
No, because if I run Prague 3B now, I'm not going to get the same obnoxious kitchen timer. If I run Prague 3B now, and it imports Prague 2B, then p2.main will be executed, but it's not going to display anything.
I got it.
You got it.
I got it.
But I have to show everyone else. I can't just claim something and then not actually show that it's true. Yeah, so, right. So the main function was executed, but it didn't do anything because underscore underscore name is prog2b, not main. Okay, so I'm happy to answer other questions after class, but the quiz is impending. The quiz should become available in the next couple of minutes, and the rules are that it's open book, open system, open web. You can have idle or Spider or PyCharm or Jupyter running. You can use Google, you can look at StackFrame. The only restriction is that you're not allowed to talk to each other, you're not allowed to send and receive email, instant messaging. Telepathy is forbidden, and I can tell. And you will have 30 minutes. So from when you start, you will have 30 minutes, and then the quiz will be yanked away from you at that point. Are we good? Okay, so just wait for the quiz to become available and then begin. I should warn you, this one's harder. But that may mean that the curve gets adjusted downwards, so don't completely freak out.